Hello class, welcome to this video on AP Stats, lesson 4.5 and 4.6 homework. Keep in mind that these concepts are from chapter 4 and lesson 2 in your book, but they're referred to as 4.5, 4.6 in the homework. So number one, researchers recruited a sample of pregnant women from prenatal care practices in Connecticut for a study about chocolate intake during pregnancy. The women who were interviewed during their first and third trimesters about risk factors for preeclampsia, an adverse pregnancy outcome, and their chocolate consumption. Women who reported regular chocolate consumption of 1 to 3 servings per week had a 50% reduced risk of preeclampsia. Is the scenario described an observational study or an experiment? Well, were there any treatments imposed? So if you look at this study, there were no treatments imposed. The women were simply interviewed, and then they reported how many they reported their chocolate consumption, right? So no treatments are imposed here. So this is an observational study. So observational study, treatments are not imposed. On the pregnant women. And in this case, the researchers simply asked them, right? They didn't assign them to chocolate or not chocolate group. They just simply asked them, okay? So researchers Okay, so identify the explanatory variable. Well, the explanatory variable in this case is the chocolate consumption, as this is probably going to lead to reduced risk of preeclampsia, right, according to the study. So the explanatory variable is the level of chocolate consumption. And then the response variable, it's going to influence the risk of preeclampsia. So we're going to say whether or not they go on to develop it. So whether or not they develop preeclampsia before giving birth. All right, so can the researchers conclude that consuming chocolate during pregnancy will cause a reduced risk of preeclampsia? Now, this is an observational study. An observational study cannot tell you causation. It can only tell you correlation, right? You need to do an experiment in order to do causation, right? Cause and effect. So the answer here is no. Since observational studies help determine correlation, not causation. There might be a confounding variable. And this confounding variable would also cause the decrease in the risk. All right, so and this is why we need to do an experiment so that we can eliminate confounding variables. All right, so number 2, does reading books help you live longer? A study was conducted on a cohort of 3,635 participants who answered questions about their reading habits via telephone survey. Researchers followed up with the participants 12 years later and concluded that book readers experienced a 20% reduction in risk of mortality over the 12 years of follow-up compared to non-book readers. A retrospective study is when investigators examine past data for a sample of individuals. A prospective study is when they follow a sample of individuals into the future. Is the study described a retrospective study or a prospective study? So this is a prospective study since it says that they followed up participants for 12 years later. So they're kind of following them into the future, right? Through time, they're not looking at past data. They're doing a follow-up years later. So that's a prospective study. So in this case, it was 12 years later. All right, so identify the explanatory variable and the response variable. So we're looking to see if reading books will help influence the mortality, right? The risk of mortality. So in this case, explanatory books, reading books, or not, right? And then the response variable is the mortality here. All right, and then potential confounding variables. So what are some variables that would also influence the response here that would also lead to the same that would also affect mortality, right? So so there's plenty of things that would affect mortality that doesn't necessarily have to do with reading books, but might be correlated, right? So if, for example, they found that someone read more books and that corresponded to reduced mortality or whatever. So maybe you might see that if the greater that someone reads, the more books that someone reads, the greater their lifespan. Well, what's a variable that's related to reading books, but also could affect lifespan? Well, maybe education level. Education level is related to reading books because, generally people with higher education are more likely to read books, right? So those with more education tend to read more books. So that's how they're related to the explanatory variable. And how does it influence the response variable? Well, those that are more educated may make better decisions health-wise. Maybe they might be more educated in how to treat how to take care of the body or their health habits, their food habits, whatever, making certain decisions. So that might be also related to that. Okay, so I'm going to say those with higher education may make better or more informed health decisions. Which would lead to longer lifespans. All right, so that's a look at confounding variables. So let's look at number 3. Does a Mediterranean diet during pregnancy improve child neural development at age 2 years? A study was conducted involving 1,221 pregnant women. The women were randomly assigned into 3 groups for 4 weeks during their pregnancies: a Mediterranean diet intervention, a stress reduction program, and usual prenatal care with no interventions. A total of 626 children were assessed at age 2 years, and it was determined that children in the Mediterranean group had higher scores. So they said the Mediterranean group had higher scores in the cognitive domain and socio-emotional domain than in the usual care group. Is this an observational study or an experiment? So in this case, it's an experiment because they assign people into groups: Mediterranean diet, stress reduction, or usual no interventions, right? So that's actually putting people into groups. So that's an experiment. You're actually doing treatment groups. So we got an experiment. Since women were randomly assigned into one of 3 treatment groups. Okay, Mediterranean diet, stress reduction, or nothing. Just to say stress reduction or nothing. Based on the results, can the researchers conclude that eating a Mediterranean diet during pregnancy caused higher scores? And the answer is yes, because they used random assignment. So they can effectively compare the difference in the 3 groups, whether they did nothing versus stress reduction versus Mediterranean diet. And they can see that the Mediterranean diet was different than the other groups in that it actually does cause the higher scores, right? So we can actually do that because of random assignment. Now the key here is random. We want to introduce, we want to do randomly assign people into groups, right? Because if it's not randomly assigned, then it's really hard to tell whether there was an effect, right? So we want to also keep that in mind. So part C, about half of the mothers who initially participated did not bring their children in for an assessment. Explain how this could affect the analysis of the results. Well, if we find that some of them, half of the mothers didn't bring their children for an assessment, then what's the difference between those mothers and then the ones who did bring their children, right? That's the key. So it's possible that the mothers that did not bring their children in for an assessment may differ in some way, right? So which could affect the results. Now, we don't know how it would affect the results, but it's possible that there's some kind of characteristic of why, they didn't bring their children versus those that did. So that may affect the scores. Okay, so we'll say the mothers who chose to bring the child in for follow-up may be different in some way from those who did not. Bring their child, which could influence the results. Again, everything in an experiment has to be controlled. So any potential variables that could lead to interpreting or misinterpreting the data, any variables that are external need to somehow be controlled. So something simple, something as simple as this, right? Any little thing needs to would potentially influence the results, or at least the interpretation of the results. All right, so all right, so number 4, does the wording of a request impact children's willingness to help? Researchers wondered if referring to a child as a helper or asking a child to help would affect their behavior. Participants were 51 4- and 5-year-old children who were randomly assigned to one of 3 groups. 17 children were assigned to the verb condition by asking them to help pick up toys. 17 children were assigned to the noun condition by asking them to be helpers when picking up toys. And the remaining were assigned to a baseline group without using help or helper. Researchers then measured the number of toys children picked up after being given the directions. Children were assigned the noun condition helped significantly more than the children in the other 2 groups. All right, so let's go ahead. We know it's an experiment because they assigned students into different groups. They did a treatment, right? They imposed a treatment. So let's draw an outline of this experiment. So first off, who are the EUs? Who are the experimental units? The experimental units are, so these are the EUs, right? EUs refer to experimental units. Who are we doing the study on? We're doing the study. Who's participating in the study? So we got 51 4 to 5-year-olds, right? Children. And then we randomly assigned them. So we did random assignment. And we assigned them into groups, right? So we assigned them into group 1. Group 1. Now, it says 17 were in each group. So group 1 is 17 4 to 5-year-olds. Group 2. Same thing. And then group 1, how did that differ? So group 1 was asked to help pick up toys. So that's the verb condition. This one was the noun condition where they asked to be a helper. And the last one is without help or helper. Okay, I should probably be more specific. They were asked to pick up toys without help or helper, but you get the idea. And then we combine the results and we compare number of toys picked up. Okay, so there's our experimental design. That's what they were. That's the outline. All right, so identify the experimental units. We did that already. It was 51 4 to 5-year-olds. 4 and 5-year-olds. Identify treatments. So the treatment was the verb condition versus the noun condition versus the baseline. So we got the verb condition, the noun condition, and baseline. Neither. All right, so those are my treatments, and then identify the response variable. This is the number of toys. Children picked up. Okay, pretty straightforward. All right, so now let's do number 5 and then number 6. To examine the efficacy of a speech pathology program, a group of 50 children was split into 2 groups. One group of children received speech services once a week for 10 weeks. The other group received speech services twice a week for 10 weeks. At the end of the 10 weeks, each child was tested and the number of speech errors they made was recorded. Which of the following describes the type of study that was conducted and the response variable for the study? All right, so observational study was conducted. So no, treatment was imposed here. So it's an experiment. So that gets rid of A and B. It has to be an experiment because we have 2 different groups. They were assigned to the groups. So an experiment was conducted for sure. The response variable here is, it says each child was tested and the number of speech errors was recorded. That's a response variable. The number of speech errors made during the testing. So that's got to be D. All right, number 6. A restaurant manager wants to examine customer satisfaction with the waitstaff at his restaurant. The restaurant has 2 seating options: sports bar, where sporting events are displayed on large TVs, dining room, which has no TVs. When customers arrive, they're asked which seating option they prefer. Then they randomly sample 20 customers from both seat options, ask them to complete a short survey. He compares the reported satisfaction level with the waitstaff and determines what customers report a higher satisfaction level with the waitstaff at the sports bar. Which of the following is a confounding variable? Depending on what they pick, right? So let's say they pick one option over the other. Well, first off, they were asked it says that they were asked, right? It says when customers arrive, they are asked which seating option they prefer. So first off, they asked which option they prefer. And let's say they chose to sit in the bar, so then they sit in the sports bar. Well, that's going to influence their satisfaction level with the waitstaff, right? Because they're in the seating option that they prefer, versus if they were in a seating option that they did not prefer. So the customer's preferred seating option, that makes sense. That may impact their the satisfaction level, and it's also related to the options, right? The options that they gave you here. Random sample of 20 customers from each seating option, that's not the confounding variable. The fact that both seating options are in the same restaurant, that's actually not a confounding variable. That's actually a good thing. We want them to be in the same restaurant so that we can effectively compare them. The restaurant only has 2 seating options. No, that's not necessarily a confounding variable. They did not ask customers about their level of satisfaction. No. So the answer is A. All right, so let's take a look at the next homework here, 4.6. So a team of researchers at MIT conducted a study to determine if debunking a false claim should occur before, during, or after reading the headline. To investigate, researchers performed the experiment with a total of 2,683 people. All participants read 36 news headlines from major media sources. 18 were true, 18 were false. That had been debunked by a fact-checking website. Participants were randomly assigned to 4 groups where true and false tags were shown before reading the headline, at the same time as the headline, after reading the headline, or not shown at all. After 1 week, participants were shown the same headlines again and asked to identify them as true or false. The researchers found showing the true or false labels immediately after reading the headlines reduced misclassification of the headlines by 25.3%, compared to 8.6% of the group that shown the labels alongside the headlines, and then 5.7% of the group shown the headlines or the labels beforehand. Describe how this experiment meets each of the following criteria in a well-designed experiment: comparison, random assignment, replication, and control. These are the 4 things you need in a well-designed experiment, right? So let's talk about comparison. Were there groups that were being compared? Well, yes, we had 4 treatment groups, right? So we had groups that we compared. There were 4 treatment groups. The first one was before, during, after, or not at all, right? Whether they show them true or false before. So those were the 4 groups. Did they have random assignments? Well, yes. So the researchers, if you go back here, the participants were randomly assigned into 4 groups. Okay. To one of the 4 groups. And then we have replication. So replication is when you have multiple in each group, right? So here, each treatment group has more than one person, so that's replication. So 2 or more people. And then we have control. Did they provide a control to help us? So what I mean by control is that in the experiment, were there variables that were controlled, right? So in this example, it says after 1 week. Okay, so after 1 week, the participants were shown the same headlines again. So they all had the same headlines. So that was a controlled variable. So everything else was controlled except for the fact that, depending on what group they were in, either they were shown the labels or they were shown during, after, right? So that was controlled. So participants see the same headlines. So in other words, all other variables other than the treatment group. So all of the variables other than treatment were controlled. Okay, so that's what you got to talk about, is talk about the variables that were controlled. Here they see the same headlines, so there's no effect on the groups in regards to that. So number 2, a statistics teacher wants to conduct a study with her students to determine if completing a review sheet is an effective way to prepare for a test. She has 180 students and would like to randomly assign half of them to complete a review sheet made by the teacher and the other half to study on their own. What is the purpose of randomly assigning students to either receive a review sheet to complete or to study on their own? So the purpose of random assignment, right? We want to randomly assign it. Well, first off, we want to see if there's an effect, right? If one causes the other. If doing a review sheet will cause them to be better prepared for the test, right? And we want to do it randomly to balance the effects of variables that are out of our control, okay? So let's explain that. I'll do that over here. We assign randomly to balance uncontrolled variables. Such as So there's variables that are at play, like students might be highly motivated versus others, right? Things like that, such as motivation, preparedness, etc., right? I'm going to put this in parentheses. So we want to control those variables. So we can determine if the treatment actually caused a change in a change in the response for the test. So in other words, we randomly assign to determine cause and effect, right? If it actually caused it, and we do it randomly so that we can balance the variables that may have impacted it. Part B, describe a process that would randomly assign the 180 students to the 2 treatment groups. Okay, so we can use a random number generator, we can use raffle, right? Those are 2 of the main methods that you can use. So here we're going to use a random number generator. We have 180 students, so from 1, we'll assign each student a number from 1 to 180. If we pick their number, then they'll be in the treatment group where they do the review sheet. Otherwise, they prepare on their own, right? So that's an easy way to do it. Assign each student a unique number, right? Or a number, so we'll put a unique number, a number that doesn't repeat, right? From 1 to 180. Use a random number generator. And we want to select 90 and 90, right? So 90 students are in one group, 90 in the other. To select 90 different numbers. In other words, numbers with no repeats. Between 1 and 180. Give a review sheet to students corresponding to numbers generated, or numbers, to numbers generated. The remaining 90 students will prepare for a test on their own. Okay, so there's your process for describing a random assignment for number 2. All right, so number 3, the Food and Drug Administration, or FDA, recently authorized a medication called omalizumab to treat milk, egg, and nut allergies. The authorization came after a study done by clinicaltrials.gov, where the primary objective was to compare the ability to consume foods without dose-limiting symptoms during a double-blind, placebo-controlled food challenge after treatment with either omalizumab or placebo for omalizumab. Both the omalizumab and the placebo were administered with an injection. Explain what is meant by double-blind, placebo-controlled in the context of this study. Okay, so let's explain the double-blind, right? And then we'll do the placebo-controlled. So double-blind means neither patients nor researchers know which treatment was received by each patient. In this case, the in context is whether they received the omalizumab or the placebo. Now, placebo-controlled means that there's some patients that that don't actually receive the treatment, but they receive an inactive treatment, right? So they receive the inactive treatment in order to compare to those that do receive the treatment, right? So that's placebo-controlled. So placebo-controlled means some patients received an inactive treatment which means an injection with no omalizumab in order to serve as a baseline to compare with the group that received the active ingredient. Okay, so that's what it means by placebo-controlled and double-blind. All right, so what is the importance of blinding in the study? Okay, so the blinding for the patients. So let's do blinding for the patients. Okay, so if for the patients, we don't want patients to change what they do if they know which treatment they received. I'm going to continue it over here. If they know which treatment they received. Also, we don't want researchers interpreting results differently. We don't want researchers interpreting results differently if they know the treatment, if they know who received the treatment. So this is the importance of blinding. So what's the importance of using a placebo? The reason why we do the placebo is so that the patients can be blinded so that they don't know which one they're receiving, okay? So so this is so patients can be kept blind to which treatment they received. Okay, all right, so So there's placebo, placebo-controlled and double blinding. So number 4, a recent study was conducted to investigate the placebo effect. In the study, 80 participants who were diagnosed with IBS were randomly assigned to one of two groups. In group 1, the 40 participants were given a placebo in the form of a sugar pill to treat their IBS. They were told they were receiving a placebo that had shown improvement in IBS through mind-body self-healing process. Interesting. So they were told that they were receiving a placebo. So interesting. So they actually told them. The remaining 40 participants received no treatment pill. So no treatment. But were given the same quality of interaction with the medical providers. The results of the study showed significant improvement in symptoms for the group who received the placebo compared to those that received no placebo. All right. So the reason why they had the group that didn't receive the placebo is to serve as a control group, right? So no placebo treatment served as the control group. As a baseline to compare to the group that received the placebo. So this is to determine the effect of the treatment of the placebo pill on IBS. Okay, explain how this study shows the placebo effect in action. So the placebo effect, remember, is you actually see an improvement or a change in the response when somebody knows that they have received a placebo, right, or receive a particular treatment. Okay, so participants experienced a response to the sugar pill. Which was the placebo, right? Received a response. Now the response is IBS improvement. Even though it had no active ingredient. And we compared that to not receiving the placebo, so no treatment at all, to serve as a baseline to see how much did that placebo actually impact it compared to what would have happened if they received nothing, right? What happened otherwise, right? So this experiment perfectly illustrates the placebo effect. All right, so number 5, a school administrator wants to know if a new method for teaching math is effective for student learning. There are 6 math classes of the same level taught by the same teacher at the school, so she implements the new method in all 6 classes. At the end of the year, final grades are recorded. Explain which criteria of a well-designed experiment are not met in this study, and provide a solution to each problem. So we want to look for the 4 aspects of a well-designed experiment. Okay, so is there comparison? Is there random assignment? Is there replication? And is there control? Okay, so it says there are 6 math classes of the same level taught by the same teacher at the school. So that means that's control, right? If it's the same level taught by the same teacher at the same school, that's control. So we do have that, right? So we have control. Do we have, let me just check this. We have control. Do we have random assignment, or do we have replication? And the answer is yes, right? we're assuming that it says 6 math classes. We're assuming each of them have more than one kid, right? So we're assuming, yes, there's replication involved. It would be kind of odd to have a class with only one student, right? So we have at least two or more students. Let's look at the comparison. So if I look at comparison, all right, so in this case, if you look at the comparison, they implement the new method and then record the final grades. But you're not comparing it to anything. So how are you comparing it? Are you comparing it to the previous year where you taught it differently, right? So we have to actually compare the methods taught, right? Okay, so it doesn't have any comparison. So we need to include a group of students from previous years. In order to compare with the 6 classes available to the study. Okay. All right, so we need comparison, and then we need to then, it didn't say anything about random assignment, so let's talk about that. It didn't say anything about assigning them to treatment groups, right? So we need, so first off, let me say, need to include a group of students from previous years to compare with the 6 classes, the group of students from previous years, and I'm going to put in parentheses, I forgot to include this, with the previous method, the previous teaching method, to compare with the new teaching method. Now, for random assignment, we need to compare to see like 3 classes to be taught with the new method versus 3 classes to be taught with the same method, right, as previous years, right? So there's no treatment groups that we can assign them to. Students not randomly assigned to treatment groups. So we can, they can randomly assign 3 classes to the new method. And other classes to the original method. Okay, and that would include random assignment. All right, so it says create an outline to show a well-designed experiment. Okay, so let's do the outline. So we have here, we have our 6 classes, the EUs. Who are we studying? There's the 6 math classes. So 6 math classes. And by the way, there's replication in this case because we're looking at the number of math classes. So we're putting the math classes into groups, and each group has more than one class. So that actually is replication, right? So earlier I mentioned replication with regards to the students, but it's actually not the students per se. It's actually the classes themselves. So we look at the classes, and we have replication because we have multiple classes, and we can put them into different groups. That's what we're going to do here. So we're gonna have random assignment, putting them into group 1, which consists of 3 math classes, hence more than one, so more replication. Group 2, 3 math classes. And group 1, they learn with a new method. And this one's the old method. Old method or original method, whatever you want to call it. And we compare the results. Compare the final grades. At the end of the year. Okay, so there's what we were talking about. All right, and that's it for that question. So now we're going to look at multiple choice. So number 6 and 7. All right, so applying a new medicated hand cream is expected to reduce dry skin. In an experiment to assess reduction in dry skin, volunteer patients will be randomly assigned to one of 2 treatments. One group will apply the new medicated hand cream and the other group will apply a placebo that looks identical to the medicated hand cream, but does not contain any medicine. Each patient will then be evaluated by a doctor to determine how much dry skin is present. The doctor recording the data is unaware of whether the patient received the medicated hand cream or the placebo. Which statement best explains blinding for this scenario? Both the patient and the doctor are blind to the treatment. Yes, that's true. So both the patient, the doctor doesn't know, the patient doesn't know which treatment. So yeah, there's your answer. That was easy. So the patient is blind to the treatment, but not the doctor. No. Neither the patient nor the doctor. No. Blinding is not possible. No. Doctor is blind. So no. So it's got to be A. All right. So number 7. Some older rugby players complain of muscle pain after practice. A study was conducted to evaluate the effectiveness of a new muscle pain relief cream. 50 volunteers who were older rugby players agreed to use the new muscle pain relief cream after every rugby practice for 1 month. At the end of the month, 54% of the volunteers reported that the new muscle pain relief cream was effective in relieving muscle pain. The company that produced the new muscle relief pain cream concluded that the new cream is more effective in relieving muscle pain than using no cream for older rugby players. Which of the following best explains why the study does not support a conclusion? Why the study does not support such a conclusion. Okay, so in this case, the reason why we cannot use cause and effect, right? We cannot is because we don't have a comparison here. Is that we don't have a way to compare this group right here with anything else. So we don't have a baseline in order to compare this group with anything else. And so because there's no comparison, we can't necessarily say that it's more effective. More effective compared to what, right? So we need to actually use maybe a placebo-controlled group, maybe a group that has the placebo, to compare what they would experience compared to the new muscle relief, the muscle pain relief versus what it would be otherwise, right? So we need a way to compare. So sample size was too small. Not necessarily. We have 50 volunteers. That's a pretty decent sample size. It's not that. We have replication going on. The study had no control group, so no way to compare. The participants were volunteers. Again, that's not necessarily the reason for the conclusion. Participants were all older rugby players. Again, that's not a reason for why we can't support the conclusion. Participants were not blind, again, so it's got to be no comparison. You have to be able to compare. All right, that's going to do it for the video, guys. Hope you found this useful and informative. As usual, I'll see you in the next one.